All right, so let's get started with 1.7, inverse relations and function. So we're going to look at how to determine whether a function has an inverse, and then how we can, based on its equation, its the table, and whatnot, and also we'll draw the graph of inverses. So inverse relations exist if and only if one relation contains B of A, then B comma A, whenever the other relation contains A comma B. So notice that those 2 points, the coordinates are just flipped around, they're switched. So when a relation is expressed as an equation, its inverse relation can be found by interchanging the independent and dependent variables. Consider the following. So look at the tables here. So if we look at the table on the left side, we have -3, -2, -3, 5, -2, 0, -1, -3, 0, -4, etc., etc. And then if you look at the inverse relation, we have 5, -3, 0, -2, -3, -1, -4, 0. Remember, these are all coordinates. And you notice the x's and the y's are switched. X's and y's are switched. All right. And so that's how you can tell by the table. Now, if you look at the relation, uh, we'll do these. Okay. So you want to, basically it's y equals, and then for the inverse, we want to get like x equals. But then you can switch that back to the y. All right, and for the graphs, we're going to talk about this line of reflection. It's going to be, the line of reflection is y equals x. Right, so this is a straight diagonal line. And if the inverse relation of a function f is also a function, then it is called the inverse function of f and is denoted by f of -1, or the inverse of f. Okay, that's the inverse of f, the inverse of f of x. All right, let's put that on the notes. All right, so then here, now we can actually test to see if a graph or if a function is going to have an inverse function based on its graph. So just like we can determine whether a function is whether a graph is a function based on the vertical line test, we can test whether the inverse is a function based on the horizontal line test. So the same thing applies if you draw a horizontal line anywhere on the graph. All right. If it crosses more than once, then the inverse is not a function. So here, just crosses once. Here, once, 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 once. All right. Some might be saying, hey, over here it crosses twice, multiple times. All right. That one's actually going down a little bit, so it's only crossing once. It's decreasing, but it's very, very, very little. Okay, just by a little bit. So that's the horizontal line test, similar to the vertical line test. All right, let's put a picture there. And you'll see that in action soon. All right, so graph each function. Oh, I should have. Okay, let me get this ready. Let me get it ready. Yeah, I'm gonna get it ready. Gonna get it ready? Yeah, I'm gonna get it ready. Here we go. Okay, I'm gonna put up Desmos here so you can see it. And I'm gonna stop sharing. Actually, let's look to see what we have here first. All right. So here we want to graph each function using a graphing calculator, then apply the horizontal line test to determine whether its inverse function exists, then just write yes or no. Okay, so what I'm going to do is I'm going to stop sharing, and I'm going to share screen 2. There we go. I'm going to move this one over here so I could see the problems. And we're going to graph. So I'm going to graph the first one. You can write f of x, but I'm just going to write y equals x squared plus 6x plus 9. And I got that squared by doing the caret. So shift 6. You can also do here squared. Okay. All right. So here, are there any vertical lines that are going to cross that graph more than once? Yeah, all over the place, right? We have y equals 1, y equals 2. So y equals 2, right? Y equals 10. All right. All those lines are crossing twice. So because they cross twice, the inverse of this is not going to be a function. The inverse is not going to be a function. All right. So that was the first one. So the first one is no. Let's look at another one that is not a quadratic. That's not a parabola. Let's look at number 5. Number 5 is the square root. So the function of x equals f of x equals the square root of 2x. All right, there's our graph. So is there any horizontal line that's crossing twice? You can actually look at the grids here. Yeah, all the grids. 1, 1, 1, 1. Yeah, they're all crossing once. Okay, so notice there's no horizontal line that crosses more than once. So this one is yes. Number 5 is a yes. All right, and let's try one of those 9 or 10. Let's do 10. So it's 8 over x minus 8 divided by x, 8 divided by x plus 2. So I'm going to hit the division first, then put 8, and then hit the down button, and then x plus 2. There we go. So will there be any horizontal line that crosses more than once? The answer is no. Yeah, here they're all crossing just once. And again, it looks like this one would, but then it's really small. There's a really small change. Okay. So it looks like it doesn't look like it's going down, but it actually is. Okay, so that one is going to be no. I mean, this is going to be yes, because uh, there's no horizontal line that crosses more than once. So this one is yes. The inverse is a function, right? So one no, five yes, 10 yes. All right. And let's call it that. This on the notes. I couldn't put the graphs. I'm sorry. Oh, let's put yes, yes. No, yes. No, yes, yes. And feel free to try any of those out if you'd like. No, yes, yeah. And you want to do the same thing here for 46 through 49. All right. So horizontal line test right away. This one, 46. No. All right. Over here, no. Here, it looks like it crosses twice, but then this one right here is an open circle. So that means that there's no point there. So it actually only crosses once right there. Right here, yeah, no space here. This one is yes. All right, so try the others. Try 48 and 49 if you'd like. No pressure, you don't have to. All right, and then tables. Oh, so you'll probably see some of these on placement tests or state tests or whatever. A lot? No, not really a lot, but you might see a couple, one or two. Here it says determine if the inverse of f exists. If so, complete the table for the inverse of f. So the way you do this, okay, is you want to think about what we did for regular functions. The way you can tell if a table is a function is if any of the x's repeat. Because remember, for a function, all inputs have exactly one output. Okay, function, all inputs have only one output. And you have the inverse of that going to be all outputs have only one input. That's one way to think about it. Okay. So here, what that means is in a table, no x's repeat. No x's repeat. All right. And for the inverse, in a table, no y's repeat. That's just a quick way to do it. Okay. So here, 50, that's a function because none of the x is repeated. Um, D1, none of the x is repeated. Yeah, these are all functions. Okay, so, but let's see if any of the y's repeat. See if they're inverse. exists. For 50, we got a negative 4, 0, 3, 5, 9, 13. None of them are the same. So all different. This is yes. No repeating. Y. Okay, so what we would do is the inverse of f of x is just going to be switched. So instead of negative 6, negative 4, it's going to be negative 4, negative 6. Instead of negative 4 and 0, it's going to be 0, negative 4. Instead of negative 1, 3, it's going to be 3, negative 1. Instead of 3, 5, it's going to be 5, 3. Instead of 6, 9, it's going to be 9, 6. And instead of 10, 13, it's going to be 13, 10. And that's it. So you just switch them to the old switcheroo. Switcheroo. All right. Now let's look at number 51. Let's look at the Y's. 14. Good. 11. Good. 8. Good. 10. Good. 11. What? We got two 11s here. We can't have two of the same Y's. So because a Y repeated, no. It does have an inverse, but it's going to be, you can take the inverse of it, but the inverse is not a function. Okay. No, the 11 repeated. That's it. All right. So feel free to try 52 and 53. Yeah, why not? Why not? All right, let's put that on the notes. Oh, that was it? Oh, that was okay. So here we have if a function passes the horizontal line test, then it is said to be one-to-one because no x value is matched with more than one y value, and no y value is matched with more than one x value. So it's the same as the all outputs have only one input, etc. So here we're going to find the inverse function. Okay, here are the steps. Determine whether the function has an inverse by checking to see if it is one-to-one using the horizontal line test. In the equation f of x, replace f of x with y and then interchange x and y. Solve for y and then replace y with f inverse of f of x. In the new equation, state any restrictions on the domain inverse of f, then show that the domain of f is equal to the range of inverse of f, and the range of f is equal to the domain of the inverse of f. Oh, what in the world? All right, so let's put that on the note. All right, you got an example. You got an example. All right, so let's do 13. So determine whether each function has an inverse function. If it does, find the inverse function and state any restrictions on its domain. So let's look at 13. So we're gonna, okay, let me open my book. There you go. Okay, so let's graph that. Here we go, graphing decimals. So we have g of x equals negative 3. and a to the b, 4 plus 6x squared minus x. And oh boy, look at that. All those horizontal lines crossing wherever, right? Yes, because we have a parabola. So parabolas mean the horizontal line test is going to fail. So this one is going to be no. All right, because the horizontal line test fails for that one. This one, no. All right. And then let's try. Hmm, I didn't do any of these ahead of time. Why don't you try 16? I'll do 17. Actually, 17 is going to be a no. Hmm. All right. Mm, yeah, I'll do 21. Not completely like 16, but similar in a way. I'll do 22. Yeah, I guess it's not too similar at all. Okay, but try 16. That one's nice. Um, Here I'm gonna graph 7 g of x equals 7 over square root of x plus 3. So let's do that. Here we go. I'm gonna click on division first. Oh no, that's not what I wanted to do. I'm gonna click on division first, and then on the numerator, I'm gonna have 7. On the denominator, I'm gonna have square root. So square root of x plus 3. There we go. All right. So does that one have an inverse? Yes, it does. It has an inverse function. And the horizontal line test passes. Yay. Oh, yay. So now we're going to do 22. Okay. So let me show you how to do the inverse. And when you see this, you're going to say, oh, really? That's it? I'm going to say, yep, that's it. All right. So you actually did this I believe you did in algebra 1. I know you did in algebra 2. All right. So what we want to do is we want to change this g of x, the function, to a y. It's easier. And then we have 7 over square root of x plus 3. All right, so we changed that g of x to a y. And now we're gonna do the whole switcheroo. We're gonna switch the x and the y. All right, we're gonna switch the x and the y, and then solve for y. This is the fun part. We get to try to get y equals. Okay, so the first thing that we want to notice is that y is in the denominator. So we want to bring it to the top. So the way we do that is we're going to multiply both sides by that square root of y plus 3. We're going to multiply both sides by the denominator. So we have x times square root of y plus 3. And if you do that, you're going to cancel that out. You get equals 7. And if you wanted to see that again, let me do it here. So multiply both sides by the denominator. All right. And then we want to get, because it has that radical, we want to get the radical by itself. So we're going to get rid of this times x. So how do you get rid of that times x? Opposite of multiplying is dividing. Yeah, you just do opposite operations, inverse operation. So we're going to divide both sides by x. Here we go. These cancel out and we get y, square root of y plus 3 equals 7 over x. And now, it's like an onion. You just do one step at a time. You peel one layer at a time. Now we have this next layer, which is the square root. So how do you get rid of a square root? The opposite of squaring is square rooting. Wait, opposite of square rooting is squaring. So we're going to square both sides. Square this, and I'm going to put parentheses because I want to square the top, the numerator, and the denominator. Okay, so the square root and the square, they cancel each other out. And we get y plus 3 equals, and then 7 squared is going to give us 49. And then x squared is going to give us x squared. And then you think we're finished. No, no, we're not done yet. Now we want to get that y by itself, so we need to get rid of that plus 3. So the opposite of adding 3 is subtracting 3. So we subtract 3 from both sides. And you can write it like that, but the book writes it. You can leave it as 49 over x squared minus 3. I actually like it that way, but then the book writes it like this. Y equals negative 3 plus 49 over x squared. All right, and then after you solve for y, switch the y with the inverse of g of x. Everything else stays the same. And there you go. Ta-da! Okay, so that is that. Um, and here, you want to look at the domain. The domain of this one, remember, domain is going to be all real numbers unless you have an x in the denominator or an x in a radical. Here we have an x in the denominator. So what you want to do is you want to set that denominator equal to 0. And solve for x. You get x can't be square root both sides, and you get x equals 0, so x can't equal 0. However, we want to look at that original function, which is the square root. Okay. So here, Um, because of that square root, we know that um, this is going to be x is greater than 0 there. That's it. All right, so try 16 and see how it goes.